problem here where a point is given as 2, 3, and the slope is 1/2, and you're asked to put the equation of the line in standard form. Okay? So right away, again, remember that standard form is ax plus by equals c. Now the key, though, is that you're given a point and a slope, so you have to start with point-slope form. So we start with point-slope form, which looks like this. And as Ian asked the question earlier, x1 and y1 are the values that are plugged in for the actual point itself. So we plug in 2 and 3. So y minus 3, that's this right here. This is y1, and this is x1 right here. Equals the slope, which is 1/2, times x minus 2. Now, from this point, a lot of people make, not a mistake, but they take a route that's much more difficult than they have to take. If you want to put this in standard form, it's easier to get rid of the slope first. Instead of distributing the slope, so a lot of people distribute the 1/2 to everything, okay? And then in the end, you still have to double everything. Just multiply both sides by 2 to get rid of 1/2. So multiply both sides of this equation by 2. And what will happen is the 1/2 and the 2 cancel, leaving you behind with x minus 2 over here. And on this side, you're left with 2y minus 6. And now you'll notice that all the coefficients are integers. Okay? It avoids that whole having a 1/2 x problem at the end and then having to double anyway. So then take the 6, move it over by adding, and subtract the x. So we're going to have 2y minus x equals, and they're going to add 6 to both sides. Okay, we're going to end up with a 4. And in standard form, not that it really matters though, it's negative x plus 2y equals 4. But what does your book have a tendency to do? Does anybody remember?
Multiply with negative 1.
Yeah, make the x a positive always. So it doesn't really matter. X minus 2y equals negative 4. Okay, so that's what the answer would be in a textbook if you guys looked in your book. But again, the answers are the same. It's the key that you have to remember for multiple choice. You may need to manipulate stuff along the way. Jared?
Can I have my water?
Sure. Okay. All right, let's take a look at number 2. Looking at the points 2, 4, and negative 3, 7. Okay, looking at these two values. So, looking at these 2 points, what do I want to start by doing? I have 2 points. What can I always find?
The slope.
The slope. Okay? The slope. Be careful with any drinks, please, okay? Do not spill drinks on the ground. I don't know. I want to have to get a mop or something. So, change in y over change in x, which is y2 minus y1 over x2 minus x1. So, what's y2 and what's y1 in this problem?
I would do 7 minus 4.
Okay, but does it matter? Good. And I like how you said that. I would do that. Yeah. I would do 7 minus 4 also, because I see that 7 is bigger than 4, and it just makes it easier. But the bottom would then be negative, but it doesn't matter at all. So the bottom has to be now x2 minus x1. It needs to go in that order. If this is y2 minus y1, this is then x2 minus x1, which will give us 3 over negative 5. So negative 3/5 is a slope. Okay, then we can plug in like we did in the last problem and say y minus y1 equals m times x minus x1. And notice when I plugged into point slope form, I used this point up here. I could have used this point. It really does not make a difference. Now, I want to show you an alternate way to solve this problem that I think might be easier. Okay? I really do. And this is a good, when you guys have a free response problem, there's going to be a problem like this that you might want to do it this way. It just seems a little bit easier. So let's do an alternate solution for the same problem. What's not standard form, but the function form of a linear function? You always write it as f of x equals mx plus b. Okay, this is like our slope y-intercept. It's the same thing we talked about earlier. So instead of f of x, you could put a y there. What you could do is plug in both points, and then you'd have 2 equations and 2 unknowns and solve a system. And it's a little bit easier, especially if you have a matrix, because you can use your calculator on the test. So use that matrix to make it easier. So what I would do is I would plug in the 2 points here. Remember, this is f of x, this is x, this is f of x, this is x. So let's do that. We could say 4 equals m times 2 plus b. And again, that's plugging in this point. And then plug in the other point. 7 equals m times negative 3 plus b. And what you'll have is 2 variables. M and b are unknown now. Do you see that? And 2 equations.
How would you put 2 different variables in the calculator?
So, in a matrix, what we remember is that we need to have our constants on this side. So let's just reverse the order of the equations and write them like the following. Let's write it like this. 2m plus b equals 4, and negative 3m plus b equals 7. Okay? And now as a matrix, this would look like the following. And then what you'd have to do at this point is do RREF of that matrix. So you can plug in here, get your standard setup, and use a matrix. You could do the other way also. It does not matter. I'm just trying to give you guys different interpretations. Okay, of the same answer. Or you could have solved this by what method also? Easier. Elimination. Just subtract the equations, right? The b's will cancel each other. So multiply the bottom equation by negative 1, and then add the equations together. Right. Was that the question you had? Or?
Yeah, I was saying, could you use them?
Yeah, I would agree with that again. Okay?
So the answer is the y equals 4, y minus 4 equals...
Well, we got to get an answer now. Let's do it. Let's multiply the bottom equation by negative... We'll do it by hand, but the matrix works too. Multiply the bottom equation by negative 1. And what that'll do is it'll make it look like this. Okay? And then add straight down. 2 plus 3 gives me... The b's cancel, right? 4 and negative 7. M turns out to be negative 3/5. Just as we had suspected earlier. Earlier we looked at this and we had an answer, if you remember up here. See the negative 3/5 floating around there in the middle of the screen? Okay, that was the slope that we ended up getting. Once you have that slope, you can take the negative 3/5 and plug it back in either here. Either plug the negative 3/5. Oh, why does that do that? That's annoying. Plug it in up here to solve for that b that's circled there. Okay, or plug it in right here to solve for b. Again, it's up to you to decide. If you have a calculator, the matrix is an easy way to do it, or you put it in point slope form and then transfer it back into standard form. A lot of these problems emphasize your answer in standard form. Okay, so please practice that. Depending on which answer you have, going back to standard form also. If it doesn't say standard form, if it just says write an equation of the line, does not matter which form you choose. And at that point in time, I would choose the last form, which is the easiest. You plug in the slope that you got was negative 3/5, and just pick one of these points and leave it like that. There's no need to manipulate it if you're not asked to do so. Okay? Any questions on this? All right, look in your notes now. What are the topics in chapter 3? Go ahead. Nobody's a cream cheese fan? I should have gotten a half, I thought too, but I didn't want to. Just kidding. Can you make one and bring it out for him? Thank you. Yeah. So, the other topics in chapter 3. The other topics in chapter 3 are things like parallel and perpendicular lines. Why don't we do an example of that? Okay? Joe, do you mind if I take this from you? Thank you. I had to go. So, if we had, let's say we had something where it said, find a line perpendicular to the following that goes through the point 2, 3. So we're given, so let's take 2 comma negative 3. So this is the point that we're given, and we have a line that says, and we want to find a line that's perpendicular to that line, okay, perpendicular to the line given on the right, that goes through the point 2, negative 3. So already we've got a point it's going to go through. So what else do we need? A slope. What was the answer for slope whenever you're in standard form to make it easy? Do you remember? Negative. Yeah. Okay, and let's look at it. Here's the reason. Watch. If you subtract the 4x, you get 3y equals negative 4x plus 8. And then if you solve for y, you get y equals negative 4/3 x plus 8/3. So it ends up being, if we take a look, just to identify this, negative 4 over 3. Negative 4 over 3. Okay? So remember that your slope is negative a over b. Is that clear? Okay, negative a over b. So, for this kind of a problem, we know that the slope of this line is negative 4/3. But Joe, what do you know about perpendicular lines? They have what kinds of slopes?
The opposite slope.
Good. Opposite?
Inverse, whatever. But do you flip the sign?
Yes, good. And that's what I was getting at. So, negative, reciprocal. So, the slope we're looking at is going to be?
Positive 3/4.
Good. So, we flip the 4/3 to make it 3/4, and instead of a negative, we make it a positive 3/4. So now at this point in time, you're going to do exactly what we did a minute ago. You're going to take your point here and your slope here, and you're going to find the equation of the line. So a lot of these problems are the same process over and over again. It's just a matter of how you get to that point. Okay, so at this point in time, y minus y1.
Plug in the y equals mx plus b right now.
You could, let's do that. Let's do that actually.
I think
Just to make it different. Sure. So we have a point and a slope, but we can use y equals mx plus b. So we want to find b, right? So what do we do with the point?
plug in x and y.
Okay.
Negative 3 equals 3/4. Parentheses 2 plus b.
Now, what's the easy way to solve this? Or what's... Because, that might be a little bit messy. You're going to get 6/4, right? We could leave it as a fraction. What's easy? Yeah, we can multiply everything by 4 to start. Or, we could even multiply by 2.
To cancel it.
If we multiply everything by 2, watch what happens. Again, watch. If I multiply this by 2, it becomes negative 6. Multiplying this term by 2, just make that a 4. Multiplying this by 2, you get 2b. And then the 4's cancel. It's not always as intuitive to see that though. So we have negative 6
So b equals negative.
equals 3 plus 2b. That's where we're at right now.
Minus 2.
Okay, subtract the 3, we get a negative 9 equals 2b. Negative 4.5. It's a messy answer, but you know what? Doesn't always mean it's going to be an easy answer. So 3/4 x minus 4.5. Yep. Any questions on this? What about parallel lines? What are their slopes? The same. So if this problem had said a parallel line instead of a perpendicular, you would have used this 4/3 as a negative instead of positive 3/4. Okay? What else from chapter 3? Look in your notes, please. See what else you have.
What else is there?
There was a lot in chapter 3. A lot more than just this.
Overlapping lines or overlaying?
So, systems?
Yeah.
Alright, let's discuss real quick. No, add to existing recording. That's good. What other questions, guys? What other questions in chapter 3? Look at your notes. See what there was that was troubling you.
We're going over everything or just the questions?
Say again?
So are we going over everything or just people need help?
Well, what you need help with, really, just in the sake of time. The period's going to end at 9:20, so we have 7 minutes. I want to just see what there is that we can focus on.
In linear functions, there's h and k, and you have to write the equation in terms of them.
Give me an example. Do you mind, Keith?
Yeah, let me just find that page again.
Sure.
Her alphabet.
Go over like that is.
Who performed that?
I said Charlie Chaplin.
Oh, okay. Finding.
Charlie Chaplin.
Oh, wait, no, I'm wrong.
Yeah, Charlie Chaplin is something. I wrote it down.
Charlie Chaplin.
That wasn't Charlie Chaplin.
No, I read it.
Charlie Chaplin, I did a Charlie Chaplin.
What about evaluation of functions and compositions? H of g of x, g of h of x. Remember that one? That's going to be on there, so maybe we should do an example of that. Try this now. What if we had this? Yeah, we have to plug in and stuff. Oops, not h of 4. Let's say h of x equals 2x squared plus 5.
Yeah, you started a new recording, right?
K of x, yes, equals, thank you, 3x minus 1. Okay, so we have h of x and k of x. I should probably not use those variables, right? Let's try g of x so it's obvious that they're different. Now, it's okay. 5-second rule. H of x, g of x. Now, if you want to find out what h of 2 is, Ian, tell me what I should do.
You should multiply each side by 2.
Careful, and that's the common mistake. It's not h times 2.
Plug in 2 for x.
Yes, in the h function. So you do this. You take the 2 that we see here, and since it replaced x, we replace it with x in the equation there. And what we're going to end up getting is 2 squared is 4, times 2 is 8, which gives me 13. Now, again, let's just reiterate. When this is h of 2, it means you take the place of x with a 2 there, you put the 2 in for x, and you see what you end up getting for this evaluation. This is called function evaluation.
I get it. So you put in the
Whatever it is that replaces, yeah. What about this now, though? This is the tougher one. What does this tell me to do? In words, Jared, tell me what I'm doing.
Find what x, when x equals 3, what equation g, what function g is.
Good, and then?
And then the answer of g you plug in for the x.
Good, so inside out, please. Do this first. So g of 3, plug it in right up here, please. What's 3 times 3 minus 1? 8. Okay, 3 times 3 is 9, minus 1 is 8. So this is really 8. So the problem is simply asking you to do h of 8. The 9. Yeah, do you mind just packaging that for the end of the best, Anna? Thank you. So h of 8 next. H of 8. We take the 8 and plug it in up here for that x.
Okay, so that means
32 plus 5
Be careful. 8 squared is 64. Times 2 is 128. Is 133.
I'll do that.
Okay? How about a tougher one? How about a tougher? This will be on there for sure. I'm guaranteeing you right now. Well, this type of problem. Okay, and what if the problem says this?
Oh, I know.
Find the function of f evaluated now, not in a number, but when x is now equal to 2x plus 1.
So you just put it in for x, same thing.
Okay, so we put a 2x plus 1 in for the first x,
Yeah.
which is right there.
Yeah. Plus 2 times 1 blah.
Oops. Good. Very good. Now, 2x plus 1 squared is really good. Very good memory there, Joe. Okay, please don't forget that. And I can distribute this 2 to both automatically. But remember the foiling there. So you're going to get 4x squared plus 2x, which is plus 4x, plus 1, plus 4x, plus 2 minus 5. Okay? So we get 4x squared plus 8x. We have a positive 3 and a negative 5 is a minus 2. We could factor it out. If it says find the solution and factor it to its simplest form, right? We could do this.
You wouldn't say that. I didn't say that.
I mean, you never know. With multiple choice, it could be.
No.
Okay? Could look like that. But again, the idea is this. Even if an expression replaces x, you take that expression and plug it in for x in those two locations. Okay? In those two locations. Please study word problems from functions. For example, we did an example, and I'm telling you now to study. This is a good one. Remember on your test, there was a tank that was leaking fluid, and the volume was given as a function of time. Look at the test. I think it was either test 2 or test 3. But look at the example. Do that example where there was a volume v of t function, and you were told that the volume in the function after 2 hours was this much, and the volume after 3 hours was this much, and you were asked to find the function. So you were technically given x, y, and you have to find the linear function. Please look at that example from your test. Look at your linear function examples. Okay, the solutions are in Moodle, so you can see how to work through all those problems. Okay, Joe?
Especially if we have the calculator on the test, how much work do you expect?
As much as necessary. So for example like this, you might have to write it like this. MT plus B to start. Okay, thank you. Say thank you. No, now you don't have to. Start with MT plus B. Say it was given the function after 2 was 20, and then 30. And you want to set up a matrix and use it that way, you can.
Okay, that's what
Alright? Lines are parallel. What do we know? They have what kind of a solution? Same slope, okay. And there's no solution to the equations. When two lines intersect once, this point of intersection is the one solution. Okay? And if the line looks like this now, this is the tricky one, where it lies on top of one another, how many solutions? Infinite solutions. Because remember, the definition of a solution is where there's an intersection. So look at the first case over here. No intersection, no solution. Second case, one intersection, one solution. Here, well, they intersect infinitely, thus there are infinite solutions. Okay? Infinite solutions. Julian?
Are you back on the slide?
Yeah.